So now let's try to find the derivative of a function as opposed to finding the derivative at some certain point. So just a reminder, this is the equation, limit notation wise, for finding the derivative at some point x. So this is going to be a function. And just to kind of follow the pattern that we had in the last video, we were looking at x squared. So let's find out what the derivative of x squared is, what the function is. So we're solving for f prime of x. And we're going to use our good old limit notation, the definition of a derivative. So let's see what we have. We have a f of x, an f of x plus h, and an h. Well, we know what h is, and we know what f of x is, but we don't know what f of x plus h is, so let's go ahead and solve for that. F of x is simply x squared, so f of x plus h, instead of this x, we're going to have an x plus h. So that's going to look like that. And so let's go ahead and plug that in. So we have the limit as h approaches 0 of f of x plus h, which is x plus h squared, minus f of x, which is x squared, all that over h. And now let's see what happens once we take care of this x plus h squared. We get the limit as h approaches 0 of x plus h squared. That will give us an x squared plus 2 times the product of the two terms, 2xh plus an h squared minus an x squared. Now minus x squared came from here, all over h. And look at what happens. And this step should occur in pretty much every question where you're finding a derivative using this limit notation. Look at what happens to the terms that don't have an h. This x squared is the term from the x plus h squared that didn't have an h, and look at that, it cancels out with this x squared. So what should happen every time is that the terms that don't have an h in front in them will cancel out. So what you're left with is the limit as h approaches 0 of 2xh plus h squared all over h. And from there we can factor out an h on top. So we have an h times 2x plus h over h. These two h's cancel out, and we're left with the limit as h approaches 0 of 2x plus h. And at this point we can evaluate that limit. So h is going to be 0, so what we're left with is 2x. And there we have the derivative of x squared. So f prime of x is equal to 2x. And if you use the power rule, you would get the same thing. Once again, power rule is going to be in the next, either next video or next two videos. And that's how you find the derivative of x squared, or of any f of x. So now let's go ahead and look at a trickier example where you're pretty much going to use the same idea. It's just going to be a bit more algebra. So I'm going to go ahead and copy down the equation, the definition of a derivative. And we're going to use a new function. It's going to be 2x squared minus 16x plus 35. So let's go ahead and first take this derivative using the power rule. So the power rule says that we multiply this 2 down and decrease the power by 1. So that term goes to 4x. we have x to the first, so we're going to multiply this negative 16 by 1, and this x to the first goes to x to the 0, which is 1, so 4x minus 16, and this constant, the derivative of this constant, is 0. So this is the derivative. So now let's evaluate the derivative using this limit notation, and let's hope that we get this 4x minus 16. So once again, we have the f of x. We know what that is. Let's figure out what f of x plus h is. If we plug in x plus h to each of these, we get 2 times x plus h squared. And once again, I'm just putting in x plus h every time I see an x. Minus 16 quantity x plus h plus 35. And I'm going to go ahead and simplify that outside of the limit, just right here. So we have a 2 times the first term squared plus 2 times the product of the two terms plus the second term squared minus 16x minus 16h. Don't forget this negative, plus 35. Which equals, I'm just going to multiply this 2 out, 2x squared plus 4xh plus 2h squared minus 16x minus 16h plus 35. So that's what f of x plus h is. Let's go ahead and plug that into our derivative using limit notation. And when doing these problems, don't forget to write the limit. Limit notation is very important, and I guarantee that you guys are going to get points off if you forget to write the limit, since this is completely wrong without this limit sign. So f of x plus h, we said, was this, so we're going to plug that into there. So we get 2x squared plus 4xh plus 2h squared minus 16x minus 16h plus 35. And we're going to subtract from that f of x, so minus 2x squared minus 16x plus 35. All that over h equals limit notation. Never forget to use limit notation. I can't stress how important that is. Once again, you know, some of these questions, it's just going to be long algebra, and you just gotta really focus on not messing up, since that's what happens a lot. So remember the negative signs. Negative sign positive gives negative. So remember in the last question, when we got to this point, how the terms without the h's canceled out, and I said that that'll pretty much happen every time. Well, look at what happens here. We have a 2x squared here and a negative 2x squared there. Those cancel out. This term has an h. This term has an h. We have a negative 16x and a positive 16x. Those cancel out. Then we have a positive 35 and a negative 35. Those cancel out again. And, you know, that's simply what's going to happen every time. The non-h terms are just going to cancel out. And if they don't, then you're not looking too good. You probably made a mistake along the way. And, you know, I'm going to skip the factoring step. I'm just going to go ahead and cancel those out. You have an h squared here. That's why I only got rid of the exponent. Limit as h approaches 0 of 4x plus 2h minus 16. And at this point, we can evaluate the limit. So this 2h is equal to 0. And we're left with 4x minus 16, which is equal to f prime of x. And look at that. When we did it with the power rule, we got 4x minus 16. When we did it using the limit notation, we got 4x minus 16. So we know we're right. And just once again, solve for f of x plus h, plug that back in, plug f of x in, and the non-h terms will cancel out. Then you can divide by h, you cancel out the h's and then evaluate the limit, and you should get your derivative right there. And that's it.